Hello. If we connect a resistor across a DC power supply, then you get a direct current. As you can see here, the charge carriers will drift at a constant drift velocity in a constant direction. If however you connect the resistor across an AC power supply, then you're going to get an alternating current. As you can see here, the charge carriers will be periodically switching direction. The DC power supplies that's most familiar to you are probably all the different kinds of batteries. And the AC power supply that's familiar to all of us will be the main supply. So the voltages you get when you plug into the main socket is actually a sinusoidal voltage. It has an amplitude V peak and it has a fixed period T. So this sinusoidal voltage can be described by this expression V peak sine omega t. Omega is just the angular frequency, 2 pi divided by T. Unfortunately, the amplitude and the frequency of the main supply is not standardized across the entire world. The most popular are the ones using 230 volts RMS running at 50 Hz. But then there are these weird countries here running at lower voltages of about 110 volts RMS. That's why when you buy electrical appliances online, you better check whether they are designed to run at 230 volts or 110 volts. So what is Singapore's specification? Well, for Singapore, we are running at 230 volts RMS, running at 50 Hz. So what does 230 volts RMS mean? It means that the peak voltage is root 2 times of 230, so about 330 volts. So the amplitude of our sinusoidal voltage is 330 volts. It's running at 50 Hz, that means it has a period of 20 milliseconds. So each sinusoidal cycle takes 20 milliseconds. As for the angular frequency, we can calculate using 2 pi f, so it turns out to be 314 radians per second. So the expression to describe Singapore's AC supply will be 330 sine 314t. So this is the peak voltage and this is the omega. You must be wondering, why must we use an AC voltage? Why can't the main supply us with a DC voltage? And why such high voltages? Are the engineers trying to electrocute us at home? I'll be addressing these questions in the videos that are coming up next. See you! Ta-ta!